Sorry, one more time.
Is there anyone in the meeting room?
No, I can't see anybody. Nobody there.
Yeah, let's wait 1 more minute. Okay, guys, let's kick off. Ողջույն բոլորին, привет, and hi everyone again. So my name is Khachatur. I am the co-founder of Analyst Association of Romania, and I would like to welcome everyone to today's webinar hosted by Association, and we're really happy to have you here. And today we're going to explore the exciting field of data engineering. But before kicking off the conversation, I'd like to introduce the association and say that the mission of our association is to popularize and develop the business and system analysis, as well as data analysis. So we aim to promote the application of these analytical skills and in diverse fields, enhancing our participants' careers as well as the businesses they are working in. And we provide the mentorship sessions for them in order to do so, as well as the special chats with promotion of available vacancies in the field of analytics in Romania, as well as large knowledge base shared with in our social networks across the LinkedIn, Telegram, and Instagram, etc. So today we're honored to have Vanik Karslian, a top expert in data engineering, with us. Vanik is working in one of the fastest growing fintech startups in Europe in a position of senior data engineer. He will share his knowledge and experiences, helping us understand how data engineering can change businesses and overall the overview of the profession, as well as the differences between data engineering, data science, and data analytics. So without further ado, let's welcome Vanik in this webinar, and Vanik is yours. And by the way, guys, sorry, during the meeting, you will be able to write your questions in the chat, as well as raise your hand if you have any questions. And we'll either answer on your questions during the meeting or as well as at the end of the meeting. We'll have a Q&A session in the end of the meeting. Okay, Vanik, you can.
Yeah, good morning, everyone. Thank you, Khachatur, for the introduction. I'm happy to see so many people in the room interested into data engineering. Shortly about myself, I'm Vanik, senior data engineer from Bank N26. In my career, I started as a QA engineer back like 10 years ago. Then I have experience in software development as well as in DevOps. And the last 6 years, I work as a data engineer in different companies. I would like to share my experience with data engineering, the current state of the art in there. And I'll try to make this session more kind of introduction without any deep technical knowledge, just to share awareness of the data engineering and explain what we do and how our role compares to other roles in data. So I hope after this session you would understand what the data engineering means, and also how you can apply this knowledge into your daily work and improve your skills in general. So let me, and by the way, as Hachitur said, if you have any questions, just raise your hand. We'll unmute you and you'll have an option to talk to us and ask any questions. And at the end of the session, we would also have a question and answer session where everybody would have an opportunity to talk and just have a conversation with us. All right. Now I'm going to share my screen. Okay, I hope everybody sees the screen. All right,
Yeah.
so let's go.
Yeah.
So today's topic is data engineering. In this session, we will talk about what is data engineering, what this role and how it compares to other roles in data. We'd also talk about the data itself, what kind of data we have, what kind of data sources, what challenges we have working with the big data, and also explain a bit the tooling, what the data pipeline means, what the data lake means, what the data warehouse is. And at the end, we would also talk about the skill set that you need in order to become a data engineer, and how this role compares to the data scientists, and what's the skill set of the data scientists you need in order to become a data scientist, and why you would opt for data engineering in this case. Right. Let's kick it off. As a short introduction, I was bored, like to explain what the data engineering is, and just asked the ChatGPT to explain me as a kid. And here's what the ChatGPT says. Basically, it's like being a kid and making or building something with the Lego blocks. And imagine you have a big box with all of the parts, and then you want to build something meaningful from these parts. So you don't know exactly which parts you need. So you have to go into the box, pick up the parts that make sense or you think that would be useful for you, and then pull these parts, bring them together, and build something that you can enjoy with. So this is, in really simple words, what the data engineers do. But instead of parts, we use data. And so we build with this data certain solutions that you can, of course, play. But normally, other people or teams would use this data to also build something meaningful on top of this. For example, data analytics tool or business tool that would show all of your KPIs that important for your business, or machine learning solution that would detect any frauds or insecure transactions in the bank application. So there are many implications of the solutions that we build, and in this session we would cover them more. All right. Here is a schema how the data lives and how it's created, how it's stored, and how at the end it's consumed by different people. So on the left side, we have just a normal user who opens his laptop, opens the browser, and he wants to connect to, let's say, a website. And obviously in this website, once you connect, it generates the data. So all like the clicks you do, the purchases that you do, all stored in the database. And then from the business perspective, the question is like, hey, how can I understand how many users do the purchase, how many items they buy normally, do personalized suggestions and stuff like this. So for all of this, you need data, and the goal of the data engineering is to pull this data from this source, from the database of this application, into the place where the other people can do this kind of analysis. So this data is normally ends in the something called data warehouse or data lake. And on top of the data warehouse, there's a data analyst guy who would connect to the data warehouse and build a business intelligence dashboard that would show all the KPIs, how many sales the customers do, how many customers we do have in general, how many of them use the websites every month, every day, every week. So many useful KPIs that would be important for your website would be displayed with the business intelligence solutions. And the business intelligence solutions, they need data. Another example would be the data lake. The data lake is normally used by the machine learning people because we'll talk about this later as well. The data lake can provide the data on very raw level, so without any changes at all. And so we can also store different types of data like images, videos, text, tables, whatever. So this is normally what the data scientist people would need in order to train their models. And the goal of the data engineer, as we can see here in the middle, this entire part is a kind of zone of the data engineering people. So what we do normally, we go to the production database to which the application is connected, collect or scrap the data from there, and then bring this data either to the data warehouse or to the data lake, or even both, depending on the use case. So then on top of this, the data analyst people and data scientist people would be able to do their job. And again, here it's a kind of ideal example of the big corporate when you have different roles in different teams. But it could be also that all of this thing is done by just one team or one person, even if the company is small. So we'll cover this here. Basically, the role of the data engineer is just to extract the data, ensure that this data has a certain level of quality, and ensure that this data is understandable for the data analysts or data scientists, and it's easy for them to consume this data. The role of the data analyst would be to pull this data, create a useful dashboard on top of this, or conduct certain type of the research on the data, like make a report, a quarterly report to the head of the company, showing how the business is doing, showing the main KPIs and stuff like this. And the role of the data scientist would be to kind of pick this data, create a data model, train it, and ensure that this model has certain performance, certain accuracy, acceptable for the business. But normally, neither data analyst nor the data scientist would not pull the data from the source database by themselves. This would be the job of the data engineer. Again, that's the case of the ideal case of the corporate that has enough capacities, enough people, enough resources. But quite often, if you are just a startup or you have a small company and you have just few people working in IT, then this entire work may be done also by one person. So this person would be responsible for everything, basically, to collect the data from the source, bring it to a certain place where they can run big queries, or cloud storage where they can create a data lake. And then he himself can also build the models. He himself can also build the dashboards. I've had some experience with this myself, so it's a quite interesting path. But it requires from you to have a lot of skills from different areas. And normally the skills of the data scientists and the data engineers are slightly different. And therefore, it would be more efficient if you have dedicated people, dedicated teams for this. But in case if you are just a small company, you can start with small and then grow. So let's move forward. Again, here we're just showing the different areas of the work that we normally do. And as you can see here, this role intersect with each other. So as I said, even working in data analyst role, you still need to have certain knowledge about the engineering. So you have to understand how your data is working, like how often or frequent the data pipelines are triggered, what is the structure of your data, what's the volume of the data, can I run this huge table or this huge query on this table, or it's not a good idea because it will bring the production system down. So you don't necessarily need to have the deep knowledge of the data engineering, but still some level of awareness of the data engineering would be ideal, and would also help you in your data analyst career as well. Being a data scientist, basically the same thing can apply to the data scientist as well, because as a data scientist, you also need to understand, is your data fresh, for example, because you don't obviously want to train your models on the data that is stale, that is not up to date. So your model then would make wrong predictions on the production side if you use the wrong data. You also need to understand some things related to the cost, like okay, if my solution cost efficient or not. So therefore, again, in the ideal case, everybody in here should understand each other, and the data engineer himself also needs to understand what are the needs of the business intelligence people, why it's so important to have the data as fresh as possible, how to make the usage of the data more efficient. So therefore, in the ideal world, everybody in different roles would understand each other and try to make the life of each other better. Right, let's talk about data itself. We are living in the really drastic times where there are so many changes happening related to the data. There are so many sources of the data. There are also so many outcomes that you can create out of the data. So businesses, the small companies, even mid-sized companies, and especially large corporates, they invest a lot into the data solutions so they can understand their customer behavior better. They can understand how to make their business better. And therefore, for the business, it's super crucial to have working data teams and have cutting edge data solutions. So speaking of the data, I would like to now ask somebody in the chat what kind of data we have right now, what kind of shapes and formats we see working with data, just if you are not shy, just raise a hand and please speak up. Otherwise, you can also write your ideas in the chat so we can discuss them. So the question is, what kind of data we have at the moment as a sources?
So come on, guys, go ahead. Don't be shy. Chatur, maybe you? No.
No.
Okay, so give me a clue, please, Vanik.
Yeah, for example, you are a data analyst, right? What kind of data do you use? Like what kind of formats mostly?
Okay, let's imagine like tables.
Yes, yeah.
Okay, so
It's one of the options. Yeah, you have tables then.
And for example, JSONs, I don't know, file type.
Yeah,
I can collect, right?
Yes, for sure. Yeah, you have logs.
Oh yeah, right, logs, of course.
CSVs quite often. Graph data, correct. Yes, chat conversation, which is raw text, basically.
Yeah, guys finally woke up.
Yeah. It's early in the morning in Germany, so maybe some people here are sleepy or something. And as we know in Armenia, people wake up quite late, or it's just stereotype. Right. So yeah, all the ideas are correct. And actually, if we look into another slide, so if we specify different types of data, we can categorize them by different types. Like there are static files, like spreadsheets, Excel files, CSV files, JSONs, or whatever. These files are just generated and stored somewhere, so they are static. There are also APIs. So you have a website, and then you can go to this website, make a query, API query, and ask, like, bring me this report or download this report. So we have APIs, we have relational databases, Postgres, MySQL, MS SQL, any kind of SQL. We have NoSQL databases, and we also have streams. We have Kafka, RabbitMQ, Kinesis, whatever you would choose. And apart from this, we may also have, as people mentioned here, logs, graph data. So we are living in the moment where there are so many sources of the data. Again, if we think how the data differs, we can realize that it's really complex how to bring something meaningful out of this zoo with data, because there are so many things that you may interconnect with each other, and then bring some insights to the business by combining different sources. And obviously, if you would imagine doing this manually, like combining different CSV files together, then bringing it also to the Postgres database, or combining it with the Kafka queue, or any other API data, this process, if you do it manually, would be so time consuming, so heavy, and obviously not manageable. I've seen some businesses starting with this, but then at some point they just realize that it's not possible to maintain the reports that you do. They are getting out of date quite often, so you have to update them again. And the businesses would spend so much time just to align the data, process the CSV files, and make the reports out of them. So we, as data engineers, focus on the automation. So we would create scripts, solutions, applications that will scrap the data from the source, process it, make it ready to consumption, and you would not spend so much time on the manual things, but you would do this automatically by the data pipelines. And at the end, we would take these different data sources, process them, and bring them to the data warehouse, and the data warehouse is basically just a normal database, like columnar database, where you have tables. Within the tables, you would have columns, and then you, as a data analyst, in this case, would be able to run the queries of the data. So the data is already processed. You don't need to do anything on your end. You just go connect to the database and then run your analytics query. And same applies to the data lake. Would pull the data, clean it up, transform it if it's needed, and then put it in the data lake, where the data scientists would be able just to consume the data. So they would not spend their time to cleaning up the data, to combining different sources of the data together. It's all done by the data engineering team. And here, I just want to talk more about the data warehouse itself. Basically, we probably, many of us worked with the databases. So for the ones who didn't, it's just a place where the people store their data in the tables. Within the tables, you would have a set of columns in the same way as you have in the spreadsheets or Excel files. But in this case, you would be able to store more data and do more trickier queries and run certain analysis on top of the data. But the data warehouse itself, it's something even more advanced in this case. So the difference of the data warehouse compared to the normal database is that the data warehouse can work on the database scale. So it's really, really huge. You can bring your entire history of the customer reports or the entire history of the transactions. So there's so many data that you can combine together and do the queries that normally would run hours or days on the normal databases. And in the data warehouse, you can run these queries within minutes. The way how it's done by the data warehouse is that it applies certain things in order to optimize the queries. For example, they store the data not row by row, but in the columns fashion. So the data that belongs to a certain column is stored in a separate place. We'll talk about this later, but long story short, this makes the query run efficiently. They also apply massive parallel computing, which means that they would spin up multiple instances of the workers that would pick up the query. The query would be split into different parts, and each of the worker would run the query in parallel. So with that, the query would run faster and more efficient and bring the results within the minutes. And also they separate the storage and the compute part. So the best thing on this part is that you can add as much compute instances as possible. So you would split up your workload evenly. And if you see that the query is so heavy that you are not able to process it with the current number of workers, then you will spin up more workers and they will distribute the load. Again, it helps to run a massive computing and answer your queries super efficient. You would not waste hours and waiting just the database to give you the results. If we compare the data warehouse to normal databases that you have in your application, there are certain features that the data warehouse provides compared to the normal database. In the normal database, the main goal of the normal database is just to solve the transactions. The main KPI for the normal database is the transactions per second, TPS, which means that they want the database to serve as many transactions as possible. So you as a user who, for example, opens a website, you don't wait. So you open the website, you click login, and then the query to get your credentials, to get who you are, would run super fast. You would not need to wait. It would run in milliseconds latency. And obviously, you don't want to, when you run a web application or mobile application, you don't want to have longer latencies, because even, for example, if your latency is around a second, then your users would see that in the website. They would realize that your website is slow or your mobile application is slow, and therefore, for the normal databases that serve the applications, it's super important to have low latency and process as many transactions as possible. For the lab databases, the analytical databases, in this case, the data warehouses, it's not that important to have milliseconds latency because our users are data analysts. It's not just the usual users that open a website. And the data analysts, sorry, Hachatur, and they can wait. So they can wait for minutes, they can wait for like seconds. It's not a big deal. You just run your query and make yourself a coffee or something and come back and your query is ready. But this is significantly differs from the normal users on the website. And on the website, you also normally don't operate on the petabyte scales. You normally have your tables less than gigabytes inside. In certain cases, hundreds, but significantly less than in the data warehouse. And in the transactional database, you would normally have the data just from one application or from a couple of them. And in the data warehouse, you would basically bring all the data from your entire business in one place. So you can analyze, for example, the data from the marketing, combine it together with the data from sales, combine it together with your data from the backend application. So bring this all together in one place and do the joins together so you can have more insights for different teams as well. And here, just on the high level, how the data warehouse makes the queries run faster. The way how normally the backend databases store the data is just store them row by row. Imagine you have a table where you store the users and their score. For example, in this case, you have like John, Mike, and Sally, and they have a score of like 3.5, 6.4, 4.1. And when you store this data in the normal database, they would store the data row by row. Physically, the data would relocate in on the database hard disk in certain files with a small size. But the thing is that when you run the query, it means, for example, I want just to select the average score of the people. So in order to select what is the average score of the people, I need to go to the database, the database would need to extract every row from the table. Then within this row, it has to go to the column that represents the score, pick it up, then go to the next row, pick the score from there as well, and so on and so forth. And then at the end, it will do the aggregate to calculate the average. As we can see here, in order to get just one column, you still need to read the entire file. You still need to pull the ID of the user, the name of the user, and the score. So you still do a lot of reads. And this can run a bit faster. For example, in the data warehouses, normally the data is stored in the column fashion. So the score would be stored in separate files. The IDs would stored in separate files, and the name would be stored in separate files, which means that if I would run the query and I'm only interested in the score, I would just pull the files that belong to the score. So I would not read the entire information. I would reduce the amount of data I read. And these days, the read operation is the most slowest one, or one of the most slowest one in the database world. So with that, we reduce the extra reads and make the entire process run faster. Also, when you have the data stored in single place and the data has similar type, for example, in here it's just float number, it's easier to compress the data. You can apply this like the most efficient algorithm of compression, which applies to this data type, because the string data type, float data type, integer, they would have different compression algorithms. And if your data is stored row by row, then it's easier, or it's not that easy to find the proper compressing format for these data types, because they are so different. And in the columnar format, you can run the compression the most efficient one for this data type. And there are so many other techniques that make the data warehouse work faster. We are not going to cover them in this session, maybe in the next ones. But long story short is that the people who develop data warehouses, they apply a lot of effort in order to make the queries run fast and make them make even possible to run the data on petabase scale. So the pros of the data warehouse basically is that it's easy to query the data. It's just normal SQL engine. The data there is structured, which means that you have your tables, and within the tables you have columns. There are some features that support also semi-structured data like JSONs and stuff like this, but the support of this type of data is kind of limited in the data warehouse. As a cons, it's not supporting, as I said, the semi-structured data. Imagine if you want to process a video file or audio file or JSON. Obviously, with the columnar fashion with SQL, it's not built for that. So therefore, when you need to process this kind of data, you would store them in different place. Again, what kind of data warehouses we have, so you know what to use in your business. The most popular ones are Google BigQuery, Amazon Redshift, Snowflake, ClickHouse from Yandex, but there are many more. So depending on your business size, your budgets, and the infrastructure that you have, you may choose the solution that works the best for you. Data lake. The data lake is basically the place where you would store the files that don't fit in the SQL. For example, audio files, video files, CSVs, text, any other type of data that you can bring from production and you don't want to process it, just store it as raw files. This is the place where the data lake fits. Basically, the data lake is just imagine a folder in your computer, and then within this folder you have subfolders. Within subfolders you have subfolders, and so on. And at the end you have your files like CSVs, JSON, Avro, Parquet, MP3, whatever kind of data you have, you would split it up into the folders or subfolders and store it there. The main purpose of the data lake is to store the data as raw as possible. So the data scientist people would be able to use this data and train their models on top of it. Some solutions from the cloud providers, Amazon S3, probably many of us heard about this, Google Cloud Storage, Azure Blob Storage, and stuff like this. As pros, you can store your data in raw format. It doesn't depend what kind of format you have. You can store structured, semi-structured data. The storage is super cheap, and it can scale easily. As a cons, normally with the years or with time, the data lake becomes messy. Many people store different files in different places. It becomes hard to maintain. You don't sometimes understand, is it the fresh data? Do we use this data? Can we delete this data? So there are some challenges in the maintenance of the data lake. And you have to be aware of this upfront, so you don't all of a sudden hit into the unexpected costs because somebody stored the data that they shouldn't do in data lake, and you forgot about it, and then at the end of the month you get the bill. And also, as the data is stored just as files, it's not that easy to consume the data. You cannot just run SQL queries out of the box on the files within the buckets. But there are some solutions that would allow similar behavior with some tweaks. And speaking about the challenges, especially working with the big data, working with data, we always hit into some problems. For example, the API on the source side has changed. So then our solution that used to work doesn't work anymore. So we have to adjust. The tables that are defined on the backend side of the application would also change. The schema would evolve. They would add new columns, remove the old columns, and stuff like this. So you would also need to adjust your systems as a data engineer. You can also all of a sudden create too much load on the system on the backend side. So for example, you have a bank application and it's hot time, everybody's using it. And if you start also to consume the data from the application, it would start to degrade. It would show some errors on the customer side, on the client side, on the application, which is something we would like to avoid, obviously. So you have to be aware of the situations and keep an eye on how your data pipelines are doing and how the source system is doing if it's under your control. And in general, the open questions are like how to store the data, how to clean the data, and how to apply the transformations. Right. So here in this part, I just want to talk about some example tasks that we as data engineers do. So for example, there's a new data source, a new application that has the data and it has its API. And you as a data engineer is requested to create an integration. So what you would do, just, okay, check the documentation of the API source, understand how the data is structured, what kind of queries you need to do to the API, and build a library or some solution that would query the data on a certain schedule, pull the data, and store it in the data lake or data warehouse. That's sometimes is a funny task for data engineers, especially if there is a documentation, but sometimes the source APIs, they don't have documentation, so you have to discover it, understand how it works, and then it may become too heavy and not so fun anymore. Okay, quite often we see this kind of requests on the daily job. I don't know, Akop or Hachituri, we had this kind of experience, but I've seen so many people from the analyst side that just run the query. It runs for hours, and then they come to us and say, "Hey, here's our query. It runs, I don't know, like 20 minutes, 30 minutes, hour. It's too slow. What can we do about it?" And sometimes recently we had the case when the guy just posted the query, which is 500 lines in code, like 500 lines in SQL. He dropped the query to us and like, "Hey guys, this query works slow. Could you help us?" And we were like, "Okay." 500 lines. Let's see. That could be a funny task for discovery, to understand what kind of request the data analysts do. Sometimes it also gives you understanding of the business, what kind of KPIs they use, and also as a data engineer, you can think like, okay, if they have this type of queries, maybe I can apply indexes on these columns, so then the query would work faster. So you would basically try to make the life of the data analyst easier. Sometimes you can do it by adjusting the changes in the data warehouse, but sometimes it's just the query is written bad, so you need to rewrite the query in a better way so it uses the indexes and for example, doesn't select the columns that it doesn't need. Yep. Another task that we quite often do is that we created a new data source. We, for example, extracted all of the bank transactions in data lake folder, and these transactions can help the data scientists to train their model, but they don't know where the data locates, how to use this data, what kind of fields we have available in there. So normally we would provide the documentation where we say, okay, the data is located here, here are the columns, and this is how often we update the data. But quite often people just don't read the documentation, so it's easier just to talk and explain in the normal conversation or having a call.
Isn't it the developer who provides that information usually?
The information about there are multiple stages in the process. So when we first create the data pipeline, we would ask the developers to tell us what kind of columns they have, what data types they use, and stuff like this. Then we would build the data pipeline that would extract the data from the source and bring it to the either data lake or data warehouse or both. And then normally the data scientist people it could be that they would directly communicate to the developer and ask ask questions about data to the developers. But sometimes they communicate with us even more frequently. We are in more closer loop, so it's easier for them just to ask us. But it could be both. They could also ask the developers as well. That's a good point. And apart from this, we would also, it's possible as well that we would apply certain transformations on the data or combine different tables together. And therefore, the developers don't actually know what happened. So they know about the state of the raw data on the source, but they don't know how we changed the data, how we combined the data, what kind of new columns we created, or how we cleaned up the data. And therefore, in this case, we would be the more appropriate people to ask. Yup. Another task, extract. So for example, we have our pipelines running, which extract the data on the hourly schedule. It works fine for hours, months, days, and all of a sudden it doesn't work. Which happens. There are multiple reasons why the pipeline may fail, why the extraction doesn't work. Sometimes we get it from the data analyst side, like they would complain in the chat or write us directly, like, hey, we have this data, it's super important, we need it, and we don't have new rows anymore. Could you have a look? And then we check what happened and see that, for example, the column on the source side has changed, so therefore it breaks the pipeline, or the API on the source side has changed, so it doesn't work anymore. There are like many reasons why the pipeline can fail, and for us, it's always a maintenance task to ensure that everything is working. Would normally have some data observability tools to show us at a glance what is the state of the pipelines. And when we talk about N26, we have about 2,000 of the pipeline, more than 2,000 of the pipelines. So it's a really, really huge amount of data, many data sources. And from time to time, we get in the monitoring the warnings that something broken. Normally, it's just maybe 5 pipelines, 3 pipelines out of 2,000s, but it happens. And then your normal steps here would be just to see the logs first, understand why it fails, maybe check if there's error message, or check into the database if there is any failure in there as well. So you check up multiple places to understand what's the picture, and try to detect the root cause and apply the fixes. Yeah, this is another interesting task for a data engineer. As I said, it could happen that certain queries do not run as fast as they could. And the data analyst people or data scientists, they would say, okay, guys, we need this query to run fast because we do run reports every day. For example, in our case, recently we had the case with the GDPR exports I think in Germany and in many countries in Europe. They apply this rule of the GDPR. It's about your personal data. So basically, when you are a customer of any application, you can, by the rule, you can ask this application to provide you information about yourself, like what kind of information they store about you. And we as a bank, we do have, we also have to comply with this rule. So whenever the customer asks us to tell him the information about himself that we store internally, we would need to go to different places, to different applications in the bank to pull all this information together and then bring this report to the customer. We would check, for example, all of his transactions, all of his actions in the bank, like multiple tables. And since we check multiple places, the query that runs this GDPR export started to run slower and slower because we have added recently more applications, more services that also store the customer data, and the query started to do too many joins, too many pull-ups of the data, and our goal was to make it more efficient and make it run faster. So the people on the data analyst side would run this GDPR export and can provide this information to the customer. Yeah, sometimes, especially on the large scale, but even on the small scale, you may encounter certain bugs, even in the big cloud providers like Google or AWS or Azure, and you would need to communicate to the Azure or the cloud provider and raise the question. Push them, because sometimes they just answer with the generic answer without providing any solution. So you have to really sometimes push them in order to bring you the appropriate answer, and also guarantee that they fix the bug on their system. For example, they may have a bug in the database or in the stream. Therefore, you would not be able to do your job, and the customers would start to complain. This is something you obviously don't want to have in production. Yep. And the last part I wanted to talk about is the skills. What kind of skills you need in order to work in the data engineering field. And if you are already working somewhere in data and you want to switch your role or find another opportunity in the related field, you can use this information for the switch, or to for example, to think what kind of skills you need to train the most to become a data engineer. So speaking about the hard skills, you obviously need to know the SQL, how to run the queries, how to optimize the queries. Ideally, you would also need to understand how the databases work, like down the hood, so how the indexes are created, why the query may be slow, why the database would not use the index, and how to tune certain parameters within the database. So there are many things that you could leverage, but you need to build the knowledge on it. Yeah, as I said, you would also need to run code to build the API integrations, to build the pipelines. Normally, we mainly work with Python. There are some teams that use Java, but it's not quite often. In my experience, normally people just stick with Python, and it's easier even for data analysts to understand, because many of the data analysts, they also use Python, as well as the data scientists. You also need to understand the main data frameworks that build the pipelines. For example, Airflow or Dexter. There are multiple others, but these are the most popular at the moment. You also need to understand the data warehouses, understand how they work, how to create tables in a more efficient way in there, and how to maintain it. You would also ideally need to understand the ML systems, what are the requirements for the machine learning systems, because you are basically building the solutions for them, and you have to have some at least basic knowledge of ML, like what's important for them, why they need certain type of features and stuff like this. Also, in my experience, we also worked a lot with the BI solutions. So there, as a data engineer, you would need to understand how to make the dashboards faster, for example, as people who provide the data. The queries from the BI side, from the dashboard, can be really slow, and therefore you need to check with the BI people who build the dashboard what kind of queries they run, so you would provide them a better solution, maybe pre-calculate certain things or aggregate certain things up front, so the query would run faster. And also PI, like personal identifiable information. So it's something that you have to take care of, especially in the bank, because not all of the people, even data analysts, should have access to the PI data, like to your name, surname, your bank accounts, and stuff like this. So whenever you work with this kind of data, you have to be aware who has access to what. You have to have ideally the data governance team who manages the accesses. But if it's not the case, then it's on your shoulders, and you have to be really, really careful, because that can bring the company into huge troubles, especially in Germany, or any other countries as well. Soft skills, I think this is something that people in IT tends to underestimate, but I would say the quite often even more important than the hard skills, because as we talked already, we work with multiple people, many teams are involved. You have data scientists, you have data analysts, you have backend team. You have to communicate a lot, especially as a data engineer. So you have to be fine with this. It's not something like, okay, I'm working in IT, so I don't talk to the people. No, it's not. And also for the people who work with you, it would be easier if you can explain your ideas, your solutions, and tell the people why you did that, and bring some motivation. Uh, Also, you need to understand the business language, because all the work that you do is basically for the business, and you have to understand certain terms that they use normally in the business, and try to translate your technical language into the language that is understandable by the business. And like there are many other skills that you'd obviously need, as in many other jobs, but we can talk about this in person if you want. And let's move forward. So currently, at the moment, there are so many people interested into the data scientist role, or ML engineer, or stuff like this. And I myself, I tried to to work in this field as well. But at some point, I just realized that I like the engineering more. And for the data science, you need a certain type of skill set or even mindset. And it's not the role for everyone, despite it's on trend right now. For example, in data science, you normally need to know a lot of math theory to understand how to train your models, what kind of models you have, understand the uh, hard theory from the university, also read a lot of scientific papers, and you have to have certain mindset to do so. Also, you have to understand, if you are having more kind of engineering skill set or mindset, you like to solve the tasks, your engineering problems, or you don't like so much theory, but you like to play with hands, with something. In this case, you can opt, for example, to ML engineering. So the ML engineering role is basically for the people who would take the already created models from the data scientists or ML people, and then think how to make these models productionized, how to scale this model, how to make it run in production system, where to deploy it, which cloud solution to use, and other tools. So it's more of engineering work with the data scientists. Another option would be the data engineering, where, as I explained, we work with the really heavy lifting part of moving the data, transforming the data, bringing the data in one place, cleaning. So all of this boring part that the data scientists would not like to do, we do it for them. So they are happy and they just can focus on the machine learning problems. They don't think about the data cleanups, data accuracy, transformations, and stuff like this. So if you like to have hands-on experience on the data itself, and from the engineering perspective, you can opt for the data engineering world. And as I said, as a data engineer, you still have opportunity to talk to the data scientists. You are in the closed loop with them. You would communicate with them a lot. You can also understand what kind of models they have, how they work. So there's always exchange between the teams. And if you are more engineering guy, you can also choose the data engineering role as well. Right. So I think we are close to the end. Now I would like to give you an opportunity to ask any questions about the data engineering, about my role, any other topics. Just raise your hand and ask any question.
Yeah, thanks a lot, Vanik. I think this was a great webinar, and we really now we really know more about the difference between data analyst, engineer, and scientist roles, as well as how the whole stuff is running. Guys, please feel free to ask questions in the chat, as well as raise your hands if you have any. In the meanwhile, let's take a little break from the main topic. I just wanted to ask you, Vanik, as far as I know, you started your career as a QA engineer, and then did some software engineering, DevOps, and then you made the transition to data engineering. So tell us in a couple of words how that happened and why data engineering, and do you like it more, or?
Yeah, that's an interesting question. I'm feeling like I'm in an interview. Right. So when I started as a QA engineer in one of Russian biggest corporates, VK.com. So the reason I started there is that I studied engineering, and I like to have some experience in the field, and being in QA gives you a kind of opportunity to talk to many teams and many people, because when you work in the quality assurance, you have multiple teams. You have backend team, you have front-end team, you have also the product team, and we used to work in the product, commercial product. So when the people would do the development ticket would come to me. I would do some checkups and provide feedback if it's ready to production or it needs to be reworked again. And people from the management would also come to me and ask, like, hey, why this feature is not deployed yet? is there any bug or any problem with the code or whatever. So the opportunity there is that you talk with multiple people, you understand how the IT works. And for example, if there are people who don't work in IT yet, the QA role is kind of a good entrance point to the IT. Normally, it doesn't require a lot of technical knowledge. Ideally, yes, but you can learn on the way. And for me, the QA role was just a kind of introduction into the IT. Personally, I worked there mostly on the infrastructure and environment, optimizing the test environment, optimizing the development environment, working on the automation of the tests. So therefore, with this background, it was easier for me to switch to the DevOps. And I worked in VK as a deployment manager or release manager. So basically, I would be responsible for the releases that we do in the company. So if there's a new version of the application, I would be responsible to deploy it to production to see that everything works fine. There's no problems in the dashboards. And so I was always more on kind of engineering side of the things. And then when I came to Germany, I started to study here data scientist or ML engineering. And then I just realized that ML and data science is not for me because there's less engineering part. There's a lot of theory, a lot of math. For me, it was okay, but it's not something that make fun for me. And therefore, I kind of switched to the role which is still close to the data science, but it's more on engineering side. And the background that I had in the DevOps and QA helped me also a lot in terms of understanding the architecture of the solutions and how to test them, how to make them production ready and stuff like this.
Yeah. Thanks. Jakob, do you have a question?
Yeah, guys, hi. I didn't want to interrupt you, actually. I didn't introduce myself at the beginning of our meeting. I just want to highlight that we have a question from Philippe. Am I correct in pronunciation, Philippe? Sorry if not. So I can read the question to Vanik. Vanik, so how do you present the need to have a data engineer to the company when they don't really understand the topic? Yeah, I think this is a very good question. So your answer, yeah, Vanik, go ahead.
Yeah, it's a really good question, and yeah, many of us face this question from time to time. So when we talk with the business, we have to understand their language and their motivation. So for what is important for the business, quite often than not, they are interested into either scaling their business or just acquiring more money. So you have to think how you can put the data engineering role into these directions. So if you are running a business and you want to scale, you have to show that without the data engineer, it's not possible. So you cannot acquire like X2 or X5 of customers without the data engineering role, because we would not be able to manage the data analysis. Or we do have, for example, the data science team or data analytics team. And I like to talk always with the numbers or with certain metrics. So when you work in such a team where you don't have the data engineer and you have, let's say, data analyst or data scientist, like I would say 80% of the work of the data scientist in this case would be just to make the data ready. So they would not work on the ML solutions. They would not work on the analytics solutions or bringing the insights of the data. They would just focus on connecting to the databases, bringing the data together, cleaning up the data. There's a lot of like human hours invested into the cleaning up the data, transform it, and make it available for the queries. So if you count the hours of the people who work on this, you may ask the business like, hey guys, we spend this amount of hours just to clean up the data, and we don't do any analytics tasks, we don't do any ML tasks, and it's not efficient at all because you pay us for to be a data analyst or to be a data scientist, and therefore we would need to have a data engineering team, or at least one data engineer who would pick up this heavy lifting part of the data pipelining. So the business would rethink like, okay, if we don't have the engineers and most of the hours are spent for the engineering task, and we pay these guys huge amount of salary, and people in data science, they quite often do not have quite high salaries. Yeah, maybe it's just a waste. It's just a waste for the company, and we just hire the data engineer and let the data scientists do their work, and let the data analysts do their work, so they don't focus on the stuff that they are normally not responsible for. Yeah, long story short, ideally to have some numbers, some hours, or convert it to money for the business, and also explain the opportunities that the business would have with this role.
Thanks, Vanik. Do you think this statement is right, that the data engineer role is usually introduced in large companies with a lot of data, or it's also applicable in small companies?
Yeah, it's also a good question, like when to start with the separate team of data engineering, or even with the one person in the role of data engineer. So obviously, as I said, if you are a small company and you have, let's say, a few people in data analytics team and maybe one person in data science, that is still debatable, like whether you need a data engineer. But as soon as you start to scale, as soon as you start, especially when you start to work with the large volumes of data, you would just kind of feel it on the way. If you realize yourself that you are not capable anymore to maintain the data pipelines, maintain the data quality, and you spend too much hours, then it's the point. It's the point when you start to think about the data engineering role. Like before that, it maybe doesn't make sense to introduce such a role. It still will help, but not kind of required. But as soon as your business starts to suffer, that's the point.
Okay. Any other questions, guys, in the chat? Jakob, you had the question.
Yeah, I got a question actually. So, if we back to your presentation, you know, I'm very interested in how my correspondence information is stored in social networks. So, I'm really curious about it, because I can find, for example, I can find the message of our correspondence with Khachatur 10 years ago, and it happens quite quickly, right? So, in which databases is this information stored, and how is it returned to me so quickly at the right moment? To be honest, it's impressive, since there are several billion people on Earth using some social networks apps, for example, Telegram, WhatsApp, or something like that, etc. And I can't even imagine how many messages, pictures, and so on are linked to their accounts. So, what kind of databases are these, and how do they store all of this information? Is it stored in tabular form, or in other form, or in other type of oh, I don't know, data store technology used. Can you explain this phenomena? I don't know how to call it. So
Yeah, and it's also the question like how and why Telegram starts to ask you for money when you want to have your data loaded faster, you know.
uh,
Uh,
I got it.
so I don't work as a backend engineer. Just wanted to point out. So normally the people who make this thing for the customers, and by customers I mean the users that normally use the application, not the data analysts or data scientists. So um, there are multiple solutions that people on the backend side apply, especially the cache systems. They leverage them a lot, especially for the hot data, the data that is requested quite often. For the large amount of data that is, especially for the historical data, normally people tend to load it or unload it to the some kind of storage, file storage like S3 or Google Cloud Storage. But then the downside of this is that the queries to the systems, they can be slow. So the backend systems, they have certain solutions that try to predict what kind of data should become hot, and they would just bring it back from the cloud storage to the hot storage. Um, but mainly, I would say the cache systems and the graph databases, because when you work with the social networks, the SQL model doesn't properly fit into this case because you have interconnections, many of them, and in the SQL, the data may become easily imbalanced. So in case of the social networks, they would leverage the graph databases in combination with the SQL for certain things, and they would leverage a lot of cache. But to be honest, for me, it's also kind of magic whenever I see these kind of things. Like you just load something from your like years of history back, and then it loads so fast. It's just a magic. Another question here, it's related as well, is how do the companies respect your GDPR, your personal data? It's another topic because we as a bank, we have to comply with this. We do have checkups from the financial authorities in every country. But with the social networks, it's a dark side, I would say. It's a dark side.
Okay, thank you for clarifying me this question.
Thanks, Vanik.
I think I'm done, guys. Maybe do you have any questions, Chtur?
Yeah, I think the last question, about Vanik, what do you think? What's the right path for the beginners to start their career in data engineering? And if if you can just recommend a couple of resources for the beginners to kick off.
Yes. So for the beginners, I would just recommend to start with the SQL to learn how the SQL works. Read uh, the documentation of certain database providers like MySQL or Postgres. Understand how to run the basic queries. Improve. There are certain websites where you can run your SQL queries online to train your skills. This would be basically the main skill that you would need as a starting point in data engineering. And actually, it's also a good point for the data analysts as well. So if you are not sure where to start, if you want to be a data engineer or a data scientist or a data analyst, just learn SQL. Then in the interviews, you would understand where you fit more. And we don't have so high expectations for the junior people. But the main thing would be to understand how to run the queries, and maybe how to tackle certain data problems. There's a really nice book from Kimball that explains how you can transform the data in a way that is efficient for queries. It's a kind of Bible for the data engineers. You can start with this. So that will tell you more about the data engineering and the way how we work with data, because the way how the data engineers work with data differs a lot from the backend side, because in the backend you focus on the efficiency of transactions, and here we think about the efficiency of the queries. It's slightly different thing. Yeah, and there are also a lot of online courses, Coursera, whatever other source you have, just do some courses that will help to start. We live in the world when everything is available online right now, and doing some homework would always help you to start with.
Yeah, that's true. As far as I know, the Armenian Code Academy also has data science. And by the way, on our end as well, in Analyst Association, we are in the process of creating a course for business and system analytics, and it will also include the part about the SQL queries as well. So make sure you are subscribed to our channels in social networks to not lose that opportunity to learn with us. And by the way, you also mentioned the interviews. This is another service we provide in Analyst Association. It's called the mock interviews for basically for everyone in the field of analytics. But this will be really useful for the beginners who want to start their career in the analytics domain. So you can run a mock interview with one of our experts, and we will provide. First of all, you will run through all the questions that usually analysts are asked during the interviews, and you will also be provided by the useful feedback from an expert, and he will highlight your what skills are missing on your skill set, what you need to improve, etc. So we have one more question in the chat. Which programming languages do you think are the best for data scientists? In my university, we only learn R and Python. Question from Ani. Let's answer this one as well and then wrap up.
Yeah, so here the answer is short. It's enough to know Python and R. It's more than enough. Don't expect to have more requirements from the companies. Normally, we just work with Python. R, it's not that often, but I know many companies do require R as well, but these two languages are more than enough.
Can I add one more language, Vanik?
Armenian?
No. Language of love sometimes you have to use when you use Python or something like this.
Yeah, sure. And also speaking of Python, you have to have some skills about certain libraries like pandas or NumPy. Um, so even within the language, you have certain areas to focus on. So you don't obviously want to focus on the web frameworks like Flask or a Fast API or something like this, but mainly you would focus on the data sets, processing of the data sets. So therefore, you can, when you have already the Python skills, focus on the pandas, focus on the NumPy, and the data orchestration like Airflow or Dexter. They both work with Python. And just add up from my side. So if you guys are interested into the mock-up interviews for the data engineering role as well, we can add this as a part of analysts association, so we can do it for you. No problem.
Sure. Okay, guys. Thanks a lot again, Vanik, for the great conversation and the webinar. I hope all our participants enjoyed it, and the recording of this webinar will be available shortly after we end it in the YouTube. So once again, make sure you subscribe to our channels, and let's grow together and learn together. See you next
Also,
time.
guys,
We're gonna have
sorry.
the second part. Yeah, we're gonna have also the second part of the data engineering webinar with Vanik. Soon.
Yeah, so guys, and also please go ahead, find out the link and become a membership of our community. So this webinars is for just have a simple conversations and let know each other better. Vanik, thank you one more time. I agree with Khachtur about all of his words, and I appreciate it too so much. Your presentation was so good. It was so interesting. Thank you. I'm looking forward to the second part.
Yeah, from my side, thank you guys for the opportunity to bring this topic to the public. It was also a nice session. I really love the questions, and we are going to prepare a second part, more advanced, where we talk about the data engineering in details, the tooling that we use, and the specific topics of the data engineering. And please subscribe to the channel and keep an eye on the updates. We will post it in the channel.
Thank you.
Yeah, great. So have a good day, guys. Have a good weekend. See you.
Bye
See you
bye.
guys. Bye bye.